This video will focus on a review of the properties of exponents. There are three main properties of exponents that you have discussed before. Those properties are the division property, where you can see you have x to the a divided by x to the b is equal to x to the a minus b. The multiplication property, where if you have x to the a times x to the b, that becomes x to the a plus b. And the power property, where if you have x to the a to the b, then that equals x to the a times b. Additionally, the property of division leads us to be able to rewrite any negative exponents as a positive exponent. So if you can see if you have x to the negative a, we will look at some examples where you have 1 over x to the a. Also, I'd like to apologize for the pixelation in the graphics. It's the best I can do at this moment. Let us start our discussion with the division property. As you can see, we have an example where you have x to the fifth divided by x to the third. As you do your work, we could talk about this and say, well, this is 5x's being multiplied by each other. That would be the same thing as x to the fifth. And then you would divide that by when you have 3x's being multiplied by each other. I think it is safe to assume that we all know that if you have 5 and you divide by 5, that is equal to 1. And also if you have x divided by x, that is equal to 1. And if you have x to the third divided by x to the third, that's equal to 1. Because in all three of these examples, what happens is that the division reduces the top and the bottom to equal 1. We often say cancel, but what we really mean is that when you divide, all of the values in the top and the bottom reduce to equal to 1. And that's an important concept for us as we look at this, because as we have 5x's in the numerator and 3x's in the denominator, well, you could cancel 1 and reduce 1 from each of the top and the bottom, a second one from the top and the bottom, and finally you'd reduce a third one from the top and the bottom. And what you're clearly left with is an x times x, which is equal to x squared. Now we also have to remember that there is a 1 sitting here being multiplied by the top and the bottom. Right, so we usually don't write it, but it's important because then that tells us that there should be a 1 in the bottom here and a 1 in the denominator. Of course, we don't expect you to write it if you have a 1 in the denominator, but it is assumed that you'll understand that there is 1 sitting there anyway. And that's how you end up with just x squared for x to the fifth divided by x to the third. Which, of course, with our division property, as we have written above there now, that would be the same thing as saying you have x to the fifth minus 3, because you have 5 in the numerator power, and then the power in the denominator is 3, which is still equal to x squared. So that's how the division property is able to work, and it's this concept of reduction or reducing of the numerator and the denominator with this multiple of 1 in this scenario that allows us to get to x squared. So a couple other quick examples. It's not hard to imagine that we wouldn't want to actually write out 100 x's being multiplied and 33 x's being multiplied. That's why you have a need for a properties to simplify those processes. And so this would be x to the 100 minus 33, which would just equal x to the 67th. And that would be your final answer. It would be over 1, but we wouldn't expect you to write that. Another problem worth discussing is x to the third divided by x to the fifth. So I just took this example and switched the numerator and denominator. And I am going to take the time to write out the 3 x's in the numerator and also the 5 x's in the denominator that we are multiplying out, because it's important for us to realize how when these reduce, as they did above, all 3 of them reduce in the numerator. And now you can see why it's really important that you remember that you're multiplying by 1 on the top and the bottom. Because what happens a lot of times is that, especially at the beginning, students will say, well, all of these cancel out, and then there's nothing left. Well, really, they reduce out, and you have a 1 as a multiplier left. Even though we didn't write it, there's still a 1 there. And so that's why your final answer would be equal to 1 over x squared, because now you see that you have 2 x's down here. Now, using our property, what we would see is that you have x to the third minus 5, right? Because the numerator power is first and then the denominator power is second. And what that leads us to is an x to the negative 2 if you followed that property or followed that division, and that would still be over 1 in both of these scenarios. And so our next slide, we're going to take a look at this converting something that has a negative exponent into a positive exponent, because that will be our expectation. Before we do that, I want to take one last look at this x to the third divided by x to the third. So if you have that x to the third divided by x to the third, if we use this property, we could write that as x to the 3 minus 3 all over 1, which then, of course, if you have 3 minus 3, that is x to the 0. So it's important for us to know that x to the 0 is equal to 1. That helps us in simplifying, that helps us in reducing, that helps us in all of our canceling, if you want to call it that, of our fractions. X to the 0 is equal to 1. So up top here, this would be like saying these both have a power of 1, and our second one in red there, so that's x to the 1 minus 1, which is equal to x to the 0. And you can either do it with 5s, it doesn't have to be an x or a variable. If you have 5 to the first divided by 5 to the first, that's 5 to the 1 minus 1, which is equal to 5 to the 0. And therefore, those are both equal to 1. So anything to the 0th power is equal to 1. So let's talk more about converting negative exponents. We've already shown that x cubed divided by x to the 5th is equal to x to the negative 2 using the division property, which is the same thing as 1 over x squared if we actually just went through and reduced all of the x's. It's important for us to know where this 1 up here comes from, because we should know that there is a divided by 1 because there's still always a denominator of the fraction. But this 1 right here that was in the numerator of the 1 over x squared is equivalent to this 1 that's in the numerator of the original, right? So this 1 in the denominator did not flip up to the top. It was the 1 that was in front of the x to the negative 2 that was implied there that is still in the numerator. So all you really have to do is take a look at the part that has that negative exponent, not any multiplier, if it was a 1 or a 5 or a negative 1 as this multiplier here. That stays. It's this x to the negative 2 that comes down to the bottom to get you 1 over x squared. So as we look at some other examples, we'll take a look at this one. We have 2 over x to the negative 5th. This x to the negative 5th has that negative exponent. That's going to move up to the top. And again, it moves up to the top because of the division property. It's not just something brand new. It's because of how the division property worked before, where you could say that you were going to subtract that exponent. So, meaning you could think of this as 2x to the 0th power, because anything to the 0th power is equal to 1. That's an important fact to remember in all of this. And that would be over then this x to the negative 5th. So if we used our property, this would be equal to 2 times x to the 0 minus a negative 5, which then those would both turn into positive, and so you'd have a 2x to the positive 5. And so that's why we would jump straight to this x to the negative 5th moves up to the top. This 2 doesn't move, that doesn't flip, it's only the part with the negative exponents. Our third example, we have 3y to the negative 7th. Let's think of that as 3y to the negative 7th over 1. What's going to happen is that we're going to take this y to the negative 7th and you're going to move it down to the bottom. The 3 does not have a negative exponent, right? The exponent of 3 right now is actually just a 1, so that stays where it's at. That stays on top, and on bottom you have y to the positive 7, and that would be your final answer. In our fourth example, we see we have x to the negative 10th in the bottom, so we're going to take that x to the negative 10th part and move it up to the top, which would make this x to the 17th because they both have x's. Again, if we used our property, you would write this as x to the 7 minus a negative 10 because that's our division property, which would be equal to x to the 17th. And those are both still over 1, but we don't expect you to write those when you're submitting your answers. In our fifth example, you have x to the 3rd divided by y to the negative 6th. Well, here you have a y to the negative 6th in the bottom. That's going to move up to the top. It's not going to combine with your x, but that's okay. You're just going to write them right next to each other. So x to the 3rd is going to stay in the numerator, and you're going to have y to the positive 6th in the numerator now as well. And that's still over 1, but we could just leave our final answer like that. In our final example, you see you have x to the 8th, y to the negative 9th over y to the negative 3rd. So here we have two different examples or parts that have a negative exponent. It doesn't change our concept anymore than anything else. You're going to have y to the negative 9th. That's going to move down. You could think of moving y to the negative 3rd up in that scenario. And so then this would look something like x to the 8th, and then you have that y to a positive 3rd now, and that would be over your y to the positive 9, And then you could reduce the 3 and the 9 because you have 3 on top and 9 on bottom. And this would equal x to the 8th over y to the positive 6. You could use your property where you'd have x to the 8th, which stands on its own, and y to the negative 9th minus a negative 3, which then that would become your x to the 8th, y to the negative 6th, which you could then take that y to the negative 6th part, move it down to the denominator, and you'd end back with this x to the 8th over y to the 6th. As in anything we've ever done with our properties, there are several ways to think about the problem and several ways to actually execute the problem. The concept here is this stuff in green where you're using your property. The red stuff where we're moving it to the bottom with the little arrow there, that's kind of the quick shortcut to help you quickly use that property to end up with your final answer. We will expect that any problem that has a negative